Good evening, bonsoir, Annie. Welcome to Space Trivia with Science North. This program was undertaken with funding from the Canadian Space Agency. Have a blast with us, testing your knowledge against other live viewers for a chance to win Science North swag or $50, or a Science North pass. $50 worth of swag or a Science North pass. Okay. So all you need is a mobile device to play along. Now, it's not just winning this one. If you register for all 3 Space Trivia events, you are eligible to win a Science North family membership for a whole year, even if you don't win at trivia. So right now, I would like you to go to www.menti.com and enter the code you see on the screen, or you can use your camera app to scan the QR code. So give us a thumbs up when you join, and soon you'll be able to enter your name. My name is Olathe. I'm the staff scientist for Spaceplace and Planetarium at Science North, and we have Renata running tech support in the background. Our special guest is a fellow science communicator, Frank Florian. Hey, Frank, how are you doing today?
I'm doing well. A little cold in my neighborhood here, but I'd love to do some more stargazing outside as soon as the weather warms up a bit.
Awesome. So Frank is the director of Planetarium and Space Sciences at Telus World of Science in Edmonton, Alberta. This evening, you will have the opportunity to test your James Webb Space Telescope knowledge against Frank's. But don't worry, he can't win the next prize. Okay, we have some friends with us. This is very exciting. Thanks for signing on, everyone. Remember, if you haven't signed on yet, the website that you need to join and the code are at the top of the screen. And if you haven't registered with Eventbrite for this event, make sure to register, because that's how you enter the draw for the Science North family membership. All right, so space telescopes are cool. They let us take pictures of things in space more clearly, which brings us to our first question. So answer fast to get the most points. What is this nebula named? Butterfly, the Kiss, or Bird? What do you think, Frank?
Those are all really, really good kind of names for it. Astronomers are pretty bright individuals. When they look at things in the sky, they have great imaginations to try to name these particular things they look at. And of course, when you look at this, what does that look like to you? Well, depending upon your imagination, I can see lots of different things in it. How about yourself?
Well, I came up with these, so I'll tell you at the end which one I really see when I look at it.
Oh, okay. Yeah, it's got 2 things on either side. It's got a little something in the middle there. I would probably say it's something between a butterfly and a bird, although the kiss looks kind of interesting as a thought. I don't know. 3 seconds.
Okay, get your votes in.
Okay, 5 seconds.
Right.
Can I say? Oh!
Butterfly! Yeah, it totally looks like a butterfly, doesn't it?
It does.
You know what? After looking at it for a little bit, I saw a kiss there, so I'm happy that a couple of you saw that too.
Yeah, you came up with some really good kind of ideas of what that looked like. Those 3, the butterfly, the kiss, and the bird, it could have been named any one of those.
You know what? I got it from NASA. Gotta check out their nebula quiz. Very good, very good. Okay, moving on. The next question. The James Webb Space Telescope is the most complex and powerful telescope ever built. True or false?
Well, there's a lot of telescopes built around the world. The Canada-France-Hawaii telescope on Mauna Kea is pretty sophisticated. The Hubble Space Telescope in Earth orbit is pretty sophisticated.
Yeah.
Is this going to be the most complex and powerful telescope ever built? Just looking at it, you can see it's made up of a lot of different mirror segments there. It's got to be out in space pretty far away. So, True. Oh, they're right.
It actually is, yes, the most complicated and the most powerful telescope that human beings have ever built. Oh my goodness. And it's launching pretty soon, right? Wow. Okay, next question. James Webb, the person, was NASA's second administrator, the leader of the Apollo program, or both?
Now, this one, they need to know a bit of history to figure this one out. Of course, he must have been someone very important for NASA to actually have a telescope named after him, I'm thinking.
Sure. So, Frank, can you just, for our viewers, remind us about the Apollo program, what that was?
Yeah, the Apollo program is the one that took humans to the moon. It was the leader. It was the ones that took Neil Armstrong to the moon for that first walk on the moon. So James Webb was actually the person that made that happen, at least during his tenure. He worked there from 1961 to about 1968. And it was actually his idea. He wanted to put a space telescope in orbit because he knew the importance of it. And he was a really big science person. He said, not only do I want to go to the moon, as what was the main drive back then, but I also want to do science. So that's why it's named after him. That's
awesome. And of course, now we have the Artemis program. Very exciting. We'll be talking about that next month. All right. So looking at our answers that came in, you guys, you got this one. Well done. Most of you. All right. Next question. Before being named after James Webb, the telescope was called the blank Space Telescope. So was it origami, next generation, super distant, or beehive?
I really think this one is pretty simple. Let's see what they say. Origami. I built an origami James Webb Space Telescope. My kids broke it though.
Oh dear. Well, and there is an element of origami to it, right? Like,
oh, for sure.
Got to unfold.
It might make sense, yeah, because it does have to unfold.
Oh, okay, nice. Well done. Most of you got it. And this is considered the next generation telescope after Hubble. Really, it's building on the work that Hubble did, I would say, yeah.
Yep. Great answers, guys.
Okay, let's get into some numbers. The Webb telescope is as tall, well, not quite numbers, but dimensions, as tall as a house, a 3-story building, or the CN Tower. How big is this thing?
Well, I know it's pretty big. I know that its length itself is about half a football field or so. It's pretty big that way. So if it's really that long, it should be fairly tall as well, I would assume, right? It wouldn't be a skinny thing that we have out there. So I don't think it's as tall as the CN Tower. That just wouldn't fit in the spacecraft, the Ariane 5 that's going to be launching it. But
okay, so you're ruling that out for our viewers. Nice.
We do have some people say as big as the CN Tower. They must have a really collapsible space telescope to do that work. But
it would take a really large rocket. One day we might be launching space telescopes as large as the CN Tower. But now, at this point in time, we are just launching telescopes as tall as a 3-story building. Just that. And also, as you mentioned, long as a tennis court. So this is a big telescope. So getting on to launching something this big is going to be difficult, and Webb is set to launch no earlier than December 18th, December 22nd, December 24th, or January 1st. No earlier than this.
Yeah.
So I remember when we were meeting ahead of this, you actually gave me an update on when it was being launched. I had a previous date in mind.
This launch has been delayed for many years now, not just by a few months. So it's getting closer, and I'm hoping that it will take place when they say it should. I know the answer to this one, but again, is it going to be the answer?
Yeah, you might not want to choose the one that you think you should choose. You might be closer. No, and so. Oh, here we go.
Yeah, it was.
Yeah.
But
there has been another update. It was just yesterday. So that question was for those of you who are really following this story closely. Of course, it will be launching on an Ariane 5 ECA rocket, and it will be launching from France. It's kind of cool. And that rocket is the European contribution to the mission.
Mm-hmm.
Okay, getting into the science. Which wavelengths of the electromagnetic spectrum, aka light, will Webb observe? Ultraviolet, infrared, microwave, or radio?
It's a really good question because when you look at the universe, you want to explore all wavelengths, but you sometimes want to specialize too in terms of what wavelength you're using, because different wavelengths give you different looks at the universe. And we're going to look back really far back in time with this particular telescope. So, infrared, yes.
Okay, so yeah, infrared and near infrared as well. And actually a little bit of, I guess, orange as well, like at that end of the spectrum. But mainly infrared, which I think we'll learn more about why infrared as we go. I just had a question here from the comments asking, why is Webb launching from France? Do you have an answer for that?
Well, that's a good question. Yeah, it's launching from French Guiana, and that's basically a place closer near the equator. And it's because when they looked at launching this, they needed a launch vehicle big enough that could actually handle it. And so they chose the Ariane 5, which is a rocket back when they were originally going to launch the James Webb Space Telescope. Of course, they didn't launch it, so they had to wait for so long because NASA didn't have any big launch vehicles, nor did the Russians. So, so they chose the Ariane launch vehicle for doing it. That's why it's the French Guiana, or the European Space Agency, that's providing the launch facility for it.
Cool. Very cool. All right, let's have another question. Everybody ready? Here we go. Oh, wait, before we get into that, I wanted to show you this image in case you weren't like completely clear. What do I mean? What do we mean when we say infrared? So infrared is what we experience as heat. So that's the wavelength that's just a little bit like it's longer than red. We can't detect it with our eyes, but we experience it as heat, and we actually use cameras that see in infrared. So for example, firefighters use infrared cameras to see through smoke when they're rescuing people in buildings. And the other thing that's really cool about infrared is that elongated wavelength is what visible light becomes after traveling a really long distance through expanding space to reach us. So when we want to look back in time in the galaxy, we want to look at that infrared light. So it also lets us see through not smoke so much, but gas and dust. So this is an image of the pillars of creation in the Eagle Nebula, another very cool nebula. Oh, I probably should have shown you the Orion bar at the beginning. Except this is a family show, so for all ages. Anyways, here, this image was taken by Hubble, and you can see the image on the left is in visible light, and the image on the right is in infrared. And so we can see a lot more stars than we could in visible light. So Hubble could do this, but Webb is going to do it much better.
Much better.
Okay, next question. This science mission could change our understanding of the universe. True or false? What do you think, Frank? Could this actually change our understanding of the universe?
Oh, I think so. I think this telescope's going to look so much further back into time that it's going to give us a better understanding, I think. So I would probably say true myself on this one. It's just, again, with any new development in technology, we always want to learn more. So I can only see this one actually adding to our understanding of the universe. Hey.
Yeah, all our viewers agree. Awesome. You guys got the main point. This is okay, awesome. Happy to have some people to share the excitement with. All right, so I don't need to explain it to you guys, obviously, but Hubble did change our view, and this is maybe one of the most famous Hubble images of the ultra deep field. And when you look at this, every dot, smudge, little smear that you're seeing there is a whole galaxy full of billions of stars. And we didn't see that until Hubble took that picture.
What's neat about it too is that if you hold a pin out at arm's length, that's the area of the sky that this photograph is really looking at. It's a very small part of the sky.
Really, that's very cool. And so I guess Hubble we learned that we had got confirmation that there are supermassive black holes at the center of galaxies. That was something Hubble did. What else?
Hubble's given us so much, both with our own planetary exploration of our solar system, being able to look at the planets in detail in our solar system, to, again, exploring the deep sky objects like the galaxies that we see here. Again, it's opened up a window on the universe that we didn't have before. Nowadays, with adaptive optics on big observatories, we're starting to get closer to Hubble, but not perfect. And being above the Earth's atmosphere, we get a much clearer view of things out in space in our own neighborhood.
That's right. That's what's so cool about space telescopes is they're above not only the clouds, right? We're, us stargazers are noticing the cloudy winter here. Not only are they up above the clouds, but they're up above the atmosphere too. So there's a much clearer view up there. And Hubble could see back in time. I mean, with Hubble, they observed galaxies that were, 13 billion years old, and so saw some early galaxies. So lots of neat things. But James Webb is, of course, much more powerful. You can see a comparison here of Hubble to Webb. Hubble's single piece mirror was 2.4 meters wide. While Webb has this giant golden mirror. It's made out of 18 hexagonal segments, and it is 6.5 meters wide. So it's just going to gather a lot more light, and it's doing it actually while being lighter weight, which is pretty cool tech. All right, let's get back to the questions, shall we? Yes. Oh, one last image. Those big mirrors, we're hoping that, we're expecting to see a lot more detail with them. So the images on the top, one, that with a lot of galaxies, that's from that ultra deep field, and then it's zoomed in on a particular galaxy. The images on the bottom are sort of those same images, but with as much detail as we're expecting with Webb. So a lot more detail with Webb.
Yeah, it's going to give us some incredible new knowledge for sure.
Yeah, absolutely. Okay, so Webb will allow us to see the earliest moments in cosmic time, evidence of life on distant worlds, if it exists, stars and planets forming inside of dust clouds, or all of these?
Well, the question itself, again, we're looking out into space. We're going to see so much further back in time. So I'd probably say the first one for sure. Evidence of life on distant worlds, if it exists. Well, the Hubble's been used to actually determine, some of these exoplanets around other stars, like TRAPPIST-1, where there's 7 planets that we know of.
And that TRAPPIST system, that's one of the first things Webb's going to be looking at, right?
Oh, I sure hope so, because there could be life on some of those. And
do you think there's life in the universe?
It'd be an awful waste of space if it wasn't. If there wasn't. And again, just thinking about what life we have here on the Earth, it's so diverse. Just look anywhere else out there. There's got to be life out there. I think that the universe is teeming with life. I think that's what stars are there for, and galaxies that have the stars in them, the planetary systems. I think someday we'll be like Star Trek. We'll be out there exploring these things, and we'll encounter other civilizations, I'm sure.
That would be pretty amazing.
And yeah, almost everyone got this one right. Yeah, it's all of these. It's going to explore so many different areas.
Yeah, awesome. So when we're talking about those like earliest moments of cosmic time, it's not like all the way back. It's on the cosmic time scale, right? So this image, you can see the first sort of arrow on top. Those are showing previous space telescopes, and sort of that arrow showing how far back in the time they could see. So the big white circle, that's the Big Bang, right? And then, energy started being released. At first, no light was being emitted, but the very first light that we could see was the cosmic microwave background radiation, we can still see it. So we look out, we see that all over the place. And then there's kind of a dark age, and then stars and galaxies started forming. And you can see the James Webb Space Telescope arrow is going almost all the way back to those first stars. So if Hubble was seeing toddler stars, Webb is going to be seeing like the little baby stars.
Yeah, you got to remember too, the universe itself in the early days was really, really hot, and atoms like we have today took a long time to actually kind of condense out of that really hot whatever it was that created the universe. So
yes, yeah. So it took some time, and we don't know everything there is to know about that time, or about how our galaxies really formed and how our stars formed and all of that. So this is pretty exciting. We might get to look. Well, if everything goes well, we're going to get to look back 13.4 billion years. So that's just 250 million years after the Big Bang, which in cosmic time really is like the earliest moments.
Yeah, it's really looking back far.
Yeah. All right. So Webb is an international collaboration between NASA and the European Space Agency, ESA, the Canadian Space Agency, CSA, or both?
Well, we do know that Canada is going to be involved with it because we're doing some of our astronomers in that are working on it. And of course, it's being launched from French Guiana. So I would probably say, should I say it? ESA and CSA, European Space Agency, and the Canadian Space Agency, in conjunction with NASA. Let's see. Do you think that's right, or do you think it's just one or the other?
Well, let's hear. Ooh, most of you got that one. Yes, it is a collaboration. You know what? Kind of fun fact: the Canadian Space Agency, like Canada, is also a member of the European Space Agency. So we're in there
right.
Double. Right. All right, we are halfway through. So if you need to, stretch a little or something, we are about to take a look at the leaderboard and see how everyone's doing. All right, we have got Shami leading the way with 8,610 points. And it looks like you got a lot of those points for being very fast. So well done on that, Shami. But if you are not in the lead, there is time to make a comeback. We have a few more questions. It used to be 10, but I added in an extra one for Frank.
Oh, he's going to stump me.
I'm going to try.
I did really, really well with this. There was another question inside the comments too, saying, how long will it take for us to know of the first results from Webb's explorations?
Ooh, that's a good question. So I know it's going to take like 6 months for it just to unfold. And then when are we going to start getting some data?
Yeah, probably after that. There is one of our Canadian astronauts, one of our Canadian researchers, her name, I got to look it up here, Dr. Els Peters from Western University. That's going to be one of the first to do a test with it when it's actually all ready to go. So being part of this actually gives some of our Canadian researchers the opportunity to be one of the first to actually experiment with it.
Are you giving things away, Frank?
Oh, oh dear. Okay, let's see if you remember.
Yes. Are you listening? Are you? Have you registered? Go register if you haven't registered, because remember, you have to register for all 3 to get entered in the draw for the Science North family membership. Yes. All right, ready for more questions? I'll stretch it out. Okay, let's go. Here we go. And I just want to say the Legault family, doing well. Stay in it. Stay in it. Here we go. All right, so Canada is involved. Canada has contributed a scientific instrument, a guidance sensor, or both. What has Canada contributed?
Well, I think I almost gave it away. Maybe close. Didn't say it though, but I think I know this one. Let's see.
So what are Canadians kind of famous for? What do we usually contribute when we contribute to science missions?
Well, a lot of stuff we do are things like the Earth imaging stuff, like
the whole RadarSat constellation.
Yeah, RadarSat constellations. Communication is a big one that we actually are into, because Canada was the third country to have a communication satellite in orbit, or satellite in orbit, and then of course really took off in creating communication satellites. So yeah, we've been involved in a lot of this, and yeah.
Well, apparently we're good at building some scientific instruments and guidance sensors as well.
That's right, and they're right.
Awesome. Yeah, way to go, guys.
It's going to be really important, because that's going to be pointing the spacecraft in the right direction.
Right?
Yeah, I mean, it's going to keep that thing
doesn't work. Nothing.
Yeah. If that doesn't work, they'll just blame it on Canada. No.
So here's a picture of it. So they're combined, right? So we've got our fine guidance sensor, and the instrument, the scientific instrument, is actually called NIRISS. It has kind of a cooler acronym, I think, than fine guidance sensor, which is just the FGS, or maybe it's the FGS. I don't know. I haven't talked to anyone yet. Who knows? You can tell me in the comments if you do. But NIRISS stands for Near Infrared Imager and Slitless Spectrograph.
That's a mouthful.
Yeah, you can see it. That's why we call it NIRISS. You can see it here in a clean room at NASA, at the NASA Goddard Space Flight Center back in 2012. And there's some engineers from ComDev there, which is a Canadian company that was involved, contracted by the Canadian Space Agency. I think Honeywell was also involved. And they're just putting it away for the evening to protect it from contamination. And this is a picture of the whole team that put this instrument together, with the instrument pictured behind them. So it's pretty beautiful. All right. So we'll get a little more into the science of the instrument, but first I'm just because we helped build this instrument, we contributed, and we're part of the mission and all that, will Canadian scientists take part in this science mission? Canadian scientists will take part in this science mission, true or false?
This is the one I gave away, right? I didn't know this question was coming up here, so
this is how it works though, right? We contribute something, and then we get to have some of the science, right? So with Artemis, we're contributing a Canada arm, and so we get to send an astronaut and be involved in the science mission as well.
Yeah, with the Artemis mission, I think the first orbit of the moon, again, we'll have a Canadian astronaut on board. And so which one of our new Canadian astronauts are going to be the ones going up there? It has not been decided yet.
It has not, but NASA has announced their candidate astronauts, so maybe we'll hear soon. I know I'm kind of rooting for Jenny. I gotta admit it.
That'd be a good choice. Actually, they're all good choices.
They're all good choices. They're all good choices.
Yes, I got this one right.
Yes, well done, everyone. So we've got scientists in the game. So this is Dr. John Hutchings. So he's a Canadian. He was the Fine Guidance System principal investigator. He has passed the torch on to Dr. Chris Willett, and he's one of the people that are now asking these big questions that we don't know all the answers to, and hoping that Webb will help us find them. So Dr. Willett is, he wants to know how galaxies have evolved, and Webb's going to help him with that. And he's part of the Canadian NIRISS Unbiased Cluster Survey. The acronym for that is CANUCS. So he is the CANUCS principal investigator. Love it. We also have Dr. Doug Johnston, and he's wondering, how do planets form? We don't know everything there is to know about how planets form, so he's going to use NIRIS for that. We have Dr. Wesley C. Fraser, and he's wondering why Pluto never grew up. This is something else we're going to be able to study with Webb. We've got Dr. Madeline Marshall, and she's wondering, how do supermassive black holes and galaxies grow over time? Dr. Matt Taylor is wondering, how do black holes influence star clusters in the Virgo galaxy cluster? You know, that's our galaxy cluster, but that's been updated, right? Did you hear about that, Frank?
No, that's one thing I haven't heard about. I know that we're part of the Virgo supercluster of galaxies, the local group. And it's just one branch of this big kind of spider web of galaxies.
Well, in 2015, some researchers in Hawaii were observing the way galaxies were moving, and they realized we're actually part of a much larger cluster that they called Laniakea, or immeasurable heavens.
I didn't hear about that, but yeah.
Very cool. Anyways, I digress. So yeah, black holes. We're going to learn about black holes. Professor David Lafreniere. He's wondering, are there more habitable rocky planets out there besides Earth? So again, he's actually going to be using the atmospheric. He's going to be looking at the atmospheric diversity of transiting exoplanets with NEAT, another instrument there. And then you mentioned Professor Els Peters earlier. So she's looking asking, how does star formation interact or influence the inter or circumstellar medium?
Right.
So big, amazing, interesting questions from some brilliant Canadian scientists, and lots to learn.
Yeah, you got to love missions like this where Canadians are integral to the accomplishments of this mission itself, and of course the research being done with it.
Yeah, it's pretty cool. All right, so I hope you were listening carefully, because if you were, you have some help with this next question. Which of these acronyms is not associated with Webb? Is it NIRISS, NIRIS, SOS, Canucks, GOT, NEAT, or FGS?
Oh, this is a trick one.
Oh, and I was going to make you answer before everyone else did.
I got it.
You got it. Because, of course, the real acronym is GTO. And what does that stand for? Do you know?
You know, I don't.
You just knew all the other ones, process of elimination. Well, GTO stands for Guaranteed Time Observations. So these are the critical things that the astronomers want, these guaranteed hours.
Right.
And Canada has them, of course, as we've discussed. And our Canadian scientists are guaranteed 450 hours of observing time in the first year of observations. So that is absolutely phenomenal, and some really amazing work is going to come out of that.
Yeah, that's great.
Okay, now do you know what all those acronyms stand for? Could you just name them off?
Oh, yeah, right. IRS, yeah, near infrared, image, slitless, spectrograph. Yeah.
No, me neither. Me neither. But they're pretty good. I like Canucks. Canucks is my favorite there.
They are.
And we have another leaderboard, but we have more questions too. And it looks like 3. The Lee Gold family has taken the lead. Woo!
Actually, they're all doing pretty well.
Everyone is. I mean, it's a pretty tight neck and neck here.
Sure.
Okay.
Is.
All right. So we talked about NIRIS, that slitless spectrograph. So spectrographs are used to measure the age of light, strength of a star's light, or starlight passing through a planet's atmosphere. What do we use those spectrographs for?
Well, I'd probably rule out, let's see, age of light. Is there an age of light? I don't know. I don't think so. Maybe time of
Well,
light.
it can be traveling for thousands of years to reach your eyes. So
It's rippling, the electromagnetic waves are rippling through space. So is that the light?
Oh, is anything really
Or
traveling?
is it just a rippling of the space-time continuum?
Yeah.
Strength of starlight. That's probably how much is there. Starlight passing through a planet's atmosphere. Well, that one has some.
Okay, before you answer, because I feel like you're going to give this one away. Why is it slitless? What's with that? Do you know? Because I think of spectrographs as having slits.
Yes, no. I think a slitless one basically doesn't. It gives you the full spectrum, right? It doesn't actually just give you the bright lines of an emission spectrum, nor of. But I'm not sure exactly.
All right. Well, most of you were sure that a spectrograph is going to measure the starlight passing through an exoplanet's atmosphere. That is absolutely correct, and that spectrograph picks up a spectrum, as you were mentioning. So a rainbow is like a full spectrum, but once the light has passed through an atmosphere, some of the bands of color are missing because they've been absorbed by molecules in the atmosphere. And so we can use that spectrum to find out which molecules are in the atmosphere. So if there's oxygen, maybe it's breathable air to a life form similar to us, or maybe there's water or methane. So
yeah, for oxygen, if we find oxygen, that's a sure sign that there's life on that world. It's the only way we'd find an atmosphere with oxygen is if there's life there.
Yes, and it is actually the Canucks survey. So Canucks is not an instrument; it's a survey. So there's different. The surveys have their own acronyms, and it's the Canadian Nearest Unbiased Cluster Survey, Canucks. So I guess that one is looking at clusters, probably clusters of galaxies. Yes, clusters of galaxies. Okay, random notes. Anybody sharing? On to the next question. Are you ready, Frank?
Sure.
All right, so we get to, the search for life. What could be more exciting? Let's get into some of the technical aspects of this. Why is Webb's giant golden mirror folded up for the launch and then unfolded in space? Is that so it can fit in the rocket? The space agencies are just flexing, or they're just doing it for fun?
Well, since we got 3 space agencies kind of involved here, are they all flexing their muscles? For fun, well, I'd do it for fun for sure, because it's, you want to create something that looks kind of fun and interesting. If it was already in one piece, it wouldn't be so much fun. But I think, to me, it's so it can fit in the rocket.
Yeah. They are also flexing. Sometimes they're paid to flex. Just be like, yeah, we're this awesome. And the cool thing about this folding up design, even though it has that mirror that's 6.5 meters in diameter, compared to Hubble's 2.4 meter mirror, the segmented design means that it weighs 10 times less than Hubble did. So kind of being able to fold up and not have to be one big solid mirror, not only let it fit in the rocket, but it made it a lot lighter too, which makes it easier to launch, right? Because the currency of space travel is mass. That's what my supervisor always told me.
That's right.
So here's a cool image.
And they're using a very special element too for the mirror segments, beryllium, which has doesn't expand that much when it gets out there in space, where the temperatures can drop quite a bit.
Oh, that's cool. So that would be to prevent like distortion of the mirrors?
For sure. Yeah, the beryllium itself is very lightweight and it's very strong and has very low efficient of expansion. So under stresses of different temperatures, it doesn't change its shape at all.
That's cool. And another really cool thing about this is them choosing that hexagonal shape, because of course that's like one of the most efficient packing shapes. I mean, there's examples of it in nature.
Oh, the beehive, right? Like the honeycombs, right?
Yeah, exactly. That's like a perfect example of it. And then, I mean, it's also cool because it's like the snowflake shape, which is also the Science North logo. So it's just perfect. I love it.
It's an ingenious way of making a telescope.
Yes. Okay, next question. The other thing that 6 months unfolding is building anticipation too, right? There's no shortage of anticipation with this space telescope. How many years has it taken to build and test Webb? 6, 10, 17, or 25, a full quarter of a century? How long have we been working on this?
Boy, with a complex telescope like that, you would think all those components have to work together, and again, the planning that goes into that. It's not something you do overnight for sure. It definitely takes some period of time to do that. So I'd go up a little bit. I'd say one of the higher numbers there. I'd kind of rule out 6 myself for years. So yeah, with the amount of work that need to be done, and of course with delays, yeah, it's taken a long year, 25 years.
Yeah, I can see that surprised a few of you, but it has been a really long time. I remember back in 2005 being like a little master's student and seeing a big statue of it and being told it was going to launch anytime, and just being very excited back then for it. But it is, it's very complicated, and that's why it has, it's taken a long time, but they're getting it right. And it does have a lifespan, like a designed expected lifespan of 5 years, 5.5 years actually, and it could last up to 10 years, like basically until it runs out of fuel. We know that space telescopes can last a long time. The Hubble Space Telescope, I think it launched 31 years ago.
Yeah, that's right, 1990, April.
Yeah, and it's still working.
It is. And take a look at the rovers on Mars. They only gave them a few months of life, and look, they've been going for many years. So if this is anything like that, they can make this one last for quite a long time.
Yeah, it all comes down to the fuel, right?
That's right.
Okay, next question. So why are Webb's mirrors coated in gold? What do you think? Is it all about the bling? Is it because gold reflects infrared light well? Or was there just money left over in the budget?
Well, looking at those questions there, I don't think there was much money left over in this budget, considering what it originally cost, or what it was said to originally cost, to what they're paying for it now. They might as well have the whole spacecraft covered in gold for what they paid for it.
Yeah.
Yeah.
Oh, and you guys got it. Well done. That's awesome. Yeah, gold does reflect infrared light really well, and that's actually why astronauts also have a thin coating of gold on their visors for the same reason. Very cool. Okay. Here's another one about how they built Webb. Why does Webb have a skirt? Sort of it's like a multi-layered skirt that it kind of unfurls after it launches. What's that all about? Is it just because it looks cool? Is it like kind of like you can see in the image there, maybe it's a sun shield to protect its instruments from light and heat? Or is it kind of there to keep it warm because it's way out in space?
Well, it's got to be way out in space, but with infrared light, infrared is heat radiation. So if you're trying to measure that, where would you put that? I would, if you just keep it out warm in space, no.
It's kind of like when you're stargazing, right? Like you kind of want to find a shadow. Is that you're thinking?
That's right. Yeah, it's something like that. You want to get out of the light. Yeah, there we go.
Yeah, we got some stargazers out there. People thinking about it like that. For sure, it's a big shield, and it's cool because it's always facing away from the sun too, right? So it's just it's always seeing the universe. Very, very cool. There is a big temperature difference, right? We think of space as cold, but once you have some sunlight on you, there's nothing to absorb the heat. You're out in the vacuum of space and you get really, really hot. And actually, they're expecting a temperature difference of 330 degrees Celsius between the instrument that we're trying to keep cool because we're sensing heat with it, basically, and the backside of that shield.
That's right. Yeah, we got to get those instruments down to like minus 233 degrees Celsius, like really cold, like 50 Kelvin around that temperature. It's got to be really cold in order for it to be sensitive enough to pick up this radiation, this infrared radiation from out in space.
So that's a very cool design. All right, so thinking about Webb being out there, Webb, let's finish this sentence. Webb will orbit the solar system, sun, or Earth? Who knows?
That's a really good question, because again, most of the stuff that we send up in Earth orbit, well, send up, it's in Earth orbit, so we go around the Earth. The Hubble Space Telescope's in Earth orbit too. Is that a place where we want something like this infrared telescope, though? And let's see. Or solar system's everything. The sun, of course, is too hot, if you ask me. So, but where would it orbit? This is almost like a trick question, isn't it?
A little bit, yeah, because we're used to space telescopes orbiting Earth, right? We're always like, wow, we can observe so much from low Earth orbit. We're always talking about that, but this telescope is going to be in a relatively less inhabited position. We have had telescopes out further, actually orbiting the sun, but we're not as familiar with them. So these points, maybe you can describe these better than me, but I'll give it a go. So in any kind of system in space, we've got massive objects, space-time's getting distorted, and these sort of areas, or I think of them as like little divots, these areas of stability occur in sort of the fabric of space-time. And these are called Lagrange points. And there is a Lagrange point 2 that's out past Earth, and Webb is actually going to orbit that Lagrange point in an orbit about the size of the moon's orbit around the Earth. And so that's why it needs a bit of fuel to kind of keep it in that orbit. But it's going to be kind of stable out there because of this landscape of space that's created.
Yeah, I kind of feel like it's being like on the top of a mountaintop in a way. Those points are like the top of a mountaintop. If you go one side or too far the other side, you're going to fall down that mountain and go down. But at the top, you're going to be sort of at a top where it's kind of stable. So that's what these points are. They're called Lagrange points, as you pointed out.
Okay, so you picture them as mountains. See, I was picturing them as divots.
Yeah, but remember, if it's a top like this, and if you go down, you're going to fly out, right? So if you're in a divot, you're going to stay in that divot. So I see this as basically being like a mountaintop in a way.
Very cool. So you just have to have enough sort of momentum.
Yeah, there's a few things that go in creating these Lagrange points. There's sort of balance points for gravity between these different objects. If we take a look at planets like Jupiter, they have the L5 and L4 where they have the Trojan asteroids. They're very stable places in Jupiter's orbit where you find other asteroids that are stable, that are falling or preceding Jupiter in its orbit. These are just really good places to keep things if you want to keep it in one place relative to the other bodies in it.
And far away, right? So this is 1.5 million kilometers away from Earth now, yes. Which of course is too far away for us to go and service it or to give it some more fuel, which is why it doesn't have as long, we're not going to see 30 years here because we can't go refuel, right? It's just too far away.
And someone mentions that it's shadowing Earth's orbit around the sun. And that's what it is. It's sort of shadowing. It will be going around.
Wait.
Oh.
The next question is, but I did see that comment there too. Okay, so since Webb is orbiting the sun further away than the Earth, right? It's 1.5 kilometers away. It takes longer than a year to complete an orbit around the sun. Is that true or false statement? So we know, like, Mars, for example, Mars is further away from the sun than Earth, and its year is about, it's longer.
It's much longer than ours. Ours is 365 days. I think Mars is 400.
Yeah, it's almost 2 years, right? Because I always remember we have to like fly there for 6 months and then land and then wait on the surface for a year for like, well, yeah, and then we have to fly back. It ends up taking 2 years.
That's with current space technology rockets. If we find something faster, we can probably do it differently than that. But yeah, you're right. It'd probably take a 3-year round trip to get to Mars.
So we did trick you guys. We did kind of trick you guys there. This is one of the hardest questions, I would say. But yeah, because it is in that very special point in space, the Earth is kind of pulling it with it around in the orbit. So it always stays lined up with Earth, which is great because then we can communicate with it. So we're always in communications with it. It's always facing away from the sun. It never ends up, in between the Earth and the sun where it can't observe. And it's really the next generation.
It is. But again, we just hope everything works because there's no way we can get a repair mission out there.
No, yeah, I know. That's the thing. I was reading an article today and they were like, astronomers are terrified of the launch. And I was like, well, it's a little, dramatic, but
there's a lot of nail biting, I think, during this.
There's a lot of nail biting. There are a lot of people who are really invested in this, which brings us to our last question of the evening, before we find out who our winner is of the grand prize of a family pass to Science North or $50 worth of swag. Don't forget to register to enter the draw for the family membership pass. All right, so how many people are working on the James Webb Space Telescope mission? Hundreds, thousands, or millions?
That's a really good question. Well, there's already a good, maybe 15 Canadians that are working on it. Some are maybe more than that. We don't know everyone that's working on it.
No, I didn't list everyone.
Yeah, there's a lot. And so, yeah, hundreds, thousands. Yeah, I'd probably say thousands. Yeah.
Yes, thousands. Nice. You guys are good with your orders of magnitude. So yeah, we have thousands of scientists and engineers from 14 different countries. So, more countries even than we're, partners. And also people from 300 different universities. And, it just kind of goes to show these missions do take a lot of people, and you could be one of those people if you want to be part of space exploration when you grow up.
And different people in different kind of jobs, roles. There's not everyone that's basically planning the trajectory of the mission. There's other ones working on the guidance system to the actual research. There's so many different elements here. Electronics, so if you go into electronics, you might be a technician working on it, doing things. So a lot of different people from different walks of life work to put these things together, not just scientists, really.
Even as we saw this evening, like some of the images I showed you, we have AutoCAD folks and artists. They're a really big part of this too, right? Because you need to sort of be able to imagine it before you can build it. So all of the STEAM, all of the science, technology, engineering, art, and math went into this. So yeah, whatever your interest, you could definitely find a way to contribute. All right, now let's see who our space trivia winner is for this evening. Here we go. Da-da-da-da.
Who is it?
Oh, it looks like sometimes it shuffles at the end, right? But we. Oh, that was so close. Okay, well, my condolences to the Legault family. Good job, you did very well. Xavier, nice showing. And Sri, congratulations. You are our winner this evening. Now, don't put down your phones yet. I still have a few more questions for everyone from the Canadian Space Agency who did fund this programming. Thank you, Canadian Space Agency. And first of all, Sri, I would like you to take a screenshot of your phone's screen showing you as the winner here. And I want you to send that to marketing@sciencenorth.ca. Renata is going to drop that email address in the chat. And if you're having any technical difficulties with capturing your screenshot, she can walk you through it in the chat. So that's how you're going to claim your prize. And here are our survey questions before we head out. And Frank, I'd like to know your answer to this question too. Did you have fun?
I did, yeah. I enjoy seeing the answers people actually had with it too. And I see they learned a lot too.
Awesome. Well, it was really, really awesome having you here this evening. I really appreciated getting to spend some time sharing excitement about Webb with you. Very fun. Oh, it looks like our visitors had fun too. Awesome. Okay, now this question, I only want you to answer it if you are under 18. Did you learn anything about Canada's activities in space? So what Canada is doing in space with Webb? I don't know if people can change their answers once they've put them on there. Oh yes, they can, it looks like. Or it's just growing. Wonderful. I'm really glad that you guys got to learn, because that's what it's all about. And I actually learned a lot putting this together. It's a fun way for me to learn too.
And I learned a lot too, just being here today with you.
Yeah. All right. Final question. Again, only if you're under 18. We're looking for the youth answers here. Are you more interested in STEAM, science, technology, engineering, art, and math after this experience? Now, even if you're like, no, I am maximum interested. If you're 100% interested, just go ahead and say like, yeah, because we haven't like decreased it. Maybe I don't go for it. It's okay. I did that for my son. My son's like, no, because I was completely interested already. Awesome. Okay. Thank you. Well, I'm glad some of you are. So thank you. Merci, miigwech. Thank you so much for playing. Thank you to the Canadian Space Agency for doing such amazing, cool science. And thank you, Frank, for joining us. Have a good evening. And remember, if you liked this content, please donate to Eventbrite, like and subscribe for more, and register right now for our next 2 events on the 3rd Thursday of the next 2 months. So next one's January 20th. We're going to be talking all about the Artemis program. Hopefully we'll have another fun special guest. And if you register, you stay in the running for a Science North membership, which is awesome. Okay, we do have like 3 minutes, so I'm going to take a quick look at the comments. Aw, we got some nice comments. Heather Kay says it was very interesting, and thanks. Thanks. We got some congrats for Sri. Yes, congratulations, Sri. Were you able to do your screenshot? Let us know in the comments if you could. Oh, you already have a family membership. That's fair. You could probably get some swag instead. You could negotiate it. Not as bad to get me in trouble. Okay. All right. Well, thank you so much. Thanks again, Frank. Thank you to everyone who joined in and answered questions. Congratulations, Sri, and see you next month. Keep looking up.
Bye-bye, everybody.